Volumes of prisms and cylinders, 10.5. Prism volume. We are going to talk about the volume of prisms. Here's a prism. I have a second prism. I have a third prism. What do prisms all have in common? Yep, they all have two bases that are parallel and congruent. So in this example, the bases are the triangles, right? So they are parallel, they're clones of each other, so they're congruent, and in between them we have three rectangles in this case, right? So we have all kinds of prisms available in the world. When we're talking about the volume of prisms, we're talking about all the matter that's made up in a solid like this. So how much wood is filling this space up? And so we find the volume by finding the area of the base, and we just multiply by the height, and we can get that entire volume. So the formula for the volume of a prism is base area times height. We abbreviate that as V equals capital B times H. Be sure to identify what type of base you have. So after having written this step, the next step would be to say, what is my base area? What type of base is that? In this case, it's a triangle. So we'd write BH over 2. And in this case, we could call these sides the bases, right? And so in that case, we have squares. So we would have BH, or we could even just square one of the sides, because both B and H are the same length. So you're always moving to finding what is the base area as your second step. Let's go try a couple of volume problems with prisms. Okay, find the volume of this prism. We already know it's a prism. So as we look at it, how would you name this prism? Where are the two congruent bases? And how many sides do they have? Yep, this is a pentagonal prism. So you can see that the top and the bottom, as it's sitting here, are both pentagons, and they are clones. So this is a pentagonal prism. And the fun thing about this problem is they've given us the base area. We don't have to go find the base area of this pentagon. We actually have the entire base area. So this is an easy problem. How do we find the height of the prism? Well, it is the same as in surface area. It's the distance between the bases. So here we have a height of 5 inches. So next we need to substitute the values into our formula. So there we have it. Volume equals 172 inches squared, that base area, times 5 inches, the distance between the bases, and simply multiply these together. Remember that when we multiply by 5, it's just like multiplying by 10 and then dividing by 2. So when we multiply 172 by 10, we have 1,720, and when we divide that by 2, we have 850 plus 10, right? So 860 now inches cubed. Notice with volume, we have 3 dimensions. So we have the base area, which is 2 dimensions itself, and then we have the distance between the bases. That's another dimension, 3D. So it's a 3D figure. And our units, as you see here, inches, are going to be cubed to show that 3 dimension. In our second sample, we have what looks like a rectangular prism. And so the rectangular prism, we have choices. Where do we want to, what do we want to consider to be the base? Any side could be the base, because all sides have an opposite parallel clone. So why don't we use the bottom as the base? Most people like to think of figures sitting on their bases. So if the bottom is the base, then we will say that the base area is a rectangle. So let's substitute the formula for this area into our formula. A rectangle's area is base times height, right? So we're going to find the base and height of the rectangle and then multiply by the height of the prism, which is something different. So the base and height of the rectangle base would be 10 times 4, but the height here, the second H, is the height of the prism. That's the distance between the top and bottom, you can see, is 2 centimeters. So let's substitute that information. All right, and now we can multiply these three factors together. 10 times 4 is 40 centimeters squared. 40 centimeters squared times 2 is 80 centimeters cubed. And there we go. Okay, the second topic today, and the final, is finding the volume of a cylinder. So here I have a wooden cylinder, and we can see that a cylinder is similar to a prism because they have how many bases? Yes, 2 bases. And a cylinder's bases are always what shape? Circle. So the volume of a cylinder has the same exact formula. The volume is the base area times height, right? The height is the distance between the bases. Now, the base area is always a circle, so we can write the area of a circle is, yep, pi r squared. You know that. So this is the more commonly used formula for volume of cylinders because they always have a circle as a base. Keep in mind that the volume of both of these kinds of figures is the same thing, isn't it? Base area times height. Okay, so if we have a cylinder, as you see over here on the screen, that has a height of 4 millimeters and a radius of 10 millimeters, we simply substitute this information into our plan, our formula. And so we substitute 10 millimeters for our radius. We're going to square that, right? And 4 millimeters for our height. So what do you think would be the first operation we would need to simplify? PEMDAS, exponents, right? So let's do 10 millimeters squared. What is 10 millimeters times 10 millimeters? 100 millimeters squared. Good. And so now we have a choice. We can multiply 3.14 with 100, or we can multiply 100 with 4. The order doesn't matter when we have all multiplication. So let me see if I can raise this up a little bit. There we go. I might just do 100 times 4. That's just 400. 400 millimeters cubed now. So that there we have again our 3 dimensions that we have with volume. So we have the area here in 2 dimensions and then a third dimension here. When we multiply 3.14 times 400, we end up with our answer, 1256 millimeters cubed. Excellent. Okay, if you are in the classroom, I would like you to try these 3 guided practice problems, and I want to check them before you move into your homework assignment. If you are at home or just watching this again to reinforce your knowledge here, then I would like to walk through number 2. So in class we're going to pause the video here for everyone to try it on their own, and at home if you want to continue we're going to try number 2 together. So again we have a prism, and the prism has the formula of volume equals base area times height. So we are going to have to determine what are the bases of this prism in number 2. And so you can see the bases are what shape? Triangles. So instead of writing capital B, we're going to write the formula for the area of a triangle. So the area of a triangle, you know, is base times height over 2. And that's a lowercase b. Okay, so this first h has to do with the triangles. The second h has to do with the distance between the triangles, or the height of the prism, right? Okay, good. So we're going to fill in the important information. What are the base and height of the triangle? Remember, base and height must be always perpendicular. So look at the triangle. Good. You can see 12 millimeters times 8 millimeters. Those are the perpendicular legs of the triangle. And then we have the distance between the triangles, 6 millimeters. Good. So once we have this, you're kind of on the home stretch. You just need to multiply correctly, divide by 2. So we can multiply 12 times 8. 12 times 8 is 96. Notice that millimeters times millimeters is millimeters squared. We can now divide 96 by 2. 96 divided by 2 is 48 millimeters squared. And now when we finally finish by multiplying by 6, we see that the answer, the volume of that prism, is 288 millimeters cubed. Good. good luck with your finding the volume of prisms and cylinders.